Today we're going to be talking about trigonometry, and this is used a lot in a lot of higher mathematics. It's probably one of my favorite subjects to teach. Okay, so what trigonometry is it relates angles to the sides opposite of those, to the sides opposite, adjacent, or the hypotenuse in a right triangle. So make sure you realize this is a right triangle. The sine of an angle, and that is an abbreviation for the sine function, is the opposite angle. So sine of angle A is opposite over the hypotenuse. The cosine of an angle. So the cosine is the adjacent side. So I'm going to do that side adjacent over the hypotenuse. And the tangent function is the opposite over the adjacent. And you see that there's a mnemonic device, I guess. There's a way that many students remember that, and we call it SOHCAHTOA. Okay? And so that's how I remember that, and how many teachers, many trigonometry teachers remember that. So you want to make sure that you write this down, and I often find students writing that down on the top of every test, because that tells me the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. Excuse me. And that all has to do with whichever angle you're given. You have to get an angle. Angle B's sine, cosine, and tangent are going to be different. Okay? So, find the sine, cosine, and tangent of angle P. So we call it sine. It's not sin. That's one of my biggest pet peeves, is when students write sin. Sine, cosine, and tangent. Okay, so sine of angle P. So you might want to highlight that angle. Okay, remember, SOHCAHTOA. So sine is opposite over the hypotenuse. Cosine is the adjacent to that angle over the hypotenuse. And tangent is opposite over adjacent. And that's where I'm getting those letters from. Opposite over adjacent. Okay, find the sine, cosine, and tangent of angle A. So I actually want you to stop the video now and try and do this one on your own. And then I'm going to do it and then restart the video and see if you got the right answer. So sine of angle A. And again, remember that's pronounced sine, not sin. Cosine of angle A. And the tangent of angle A. So the sine of angle A is right here. The sine, so opposite over hypotenuse, opposite over hypotenuse, 12 over 20. And we reduce that. 4 is the largest number that goes into each one of those. Cosine. So, ka. Adjacent over hypotenuse. So 16 over 20. Again, 4 goes into both of those. And tangent. TOA. In relation to angle A, the opposite over the adjacent. So 12 over 16. And that is going to be, reduce everything, 3/4. Okay, so if you're watching this video, I hope you paused it, and I hope you got those right. Okay, using your calculator to approximate the given value to 4 decimal places. On your calculator, and I'm just going to describe it to you. On your calculator, there is a button. There's a button that says SIN. Okay? First of all, you want to make sure you're in the correct mode. So mode. For mode, you press the mode button. So to making sure you're in the right mode. Press the mode button. And then arrow down. To where it says radian or degree. You want to make sure degree has that black highlight on it. Probably most of your calculators don't. So you arrow down till degree is highlighted. Make sure you press enter when you're on degree. Okay? You want to make sure these are all in degrees. Then go back to your home screen. All you have to do is press that sine button. That sine button is right to the right of the x to the -1 button. All you have to do is press sine 48 in your calculator. You don't even have to worry about a degree symbol. So I do sine 48. It says 4 decimal places. So 0.7431. Cosine. It's the button that's sitting right next to the sine button. Cosine of 70 degrees. Cosine 70 degrees. That is 0.342. Technically it's 0.2, so we're good. And then tangent is the button that's to the right of the cosine button. And that is tangent of 53. I actually have to type it in my calculator. 1.3270. Okay? So, again, make sure you're in the right mode. If you haven't been getting these, you need to check the mode in your calculator. Also, make sure you're typing the correct button. Okay, for this one, you have a fitness trainer sets the incline on a treadmill to 7 degrees. So I have 7 degrees here. The walking surface is 5 feet long. Approximately how many inches did the trainer raise the end of the treadmill from the floor? So 5 feet. But I'm looking for inches. So I need to convert this 5 feet to inches. 1 foot. I'm doing that 100% incorrectly because you want the feet to cancel. 1 foot, 12 inches. Feet cancel, so I take it, I multiply 5 times 12. Okay. So this is now 60 inches. I'm in the right units now. Now I'm looking for the opposite. So I'm looking for the opposite, and I know the hypotenuse. So to solve this, you have to think which trig function involves the opposite and the hypotenuse. So I write out my SOHCAHTOA again. SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So sine of 7 degrees, not 7D, 7 degrees is equal to my opposite over my adjacent, my hypotenuse. To get rid of that 60, I multiply by 60 and type this exactly in your calculator as it looks. 60 sine 7 and that equals 7.312 inches. Okay. To solve for an angle, so say in that problem I had to find the angle and I was given two sides. We use inverse functions. Okay, so if I needed to solve for this angle, I do the inverse sine. The reason I do that notation, on your calculator, that's the second button and then the sine button. To get the inverse cosine, second and cosine. Inverse tangent, second and tangent. So I need to use the calculator to find the measure of angle P. So I'm going to write out my SOHCAHTOA again. Okay, and let's examine what we have. We have the adjacent to angle P, and we have the hypotenuse for angle P. So I have the adjacent, I have the hypotenuse, I need to use cosine. The cosine of angle P, you know what, I'm going to take that angle symbol away, is equal to the adjacent over the hypotenuse. How do I solve for an angle? I use those inverse trig functions. Inverse cosine of 13 over 19. So I do second and my cosine button, 13 divided by 19. Let's round to 3. Oh, it says nearest 10th. So nearest 10th, that's what we get. Okay, and remember to get that in your calculator. You're pressing the second button and then the cosine button. Okay, solve the right triangle, round side measures in simplest, round each side measures in simplest radical form. Okay, so I'm finding these in simplest radical form. That's, I think, horrible wording. And angle measures to the nearest 10th. Okay, so I need to find AB. That's the hypotenuse. We've been calling the hypotenuse C. So C squared is equal to 7 squared plus 4 squared. C squared is equal to 49 plus 16. $65. I square root 65. There's no perfect squares that go in there because I look at multiples of 5. The first perfect square is 25, and 25 doesn't go into 65. So C is equal to 65. And just so you know, when it says solve the triangle, that means find all the angle measures and the side lengths that weren't given to us. So now you have a choose your own adventure. And I love those books as kids. I don't know if you guys read those books as kids, where I can pick, do I want to use angle A or angle B? I'm going to use angle A. So I look at what the sine of angle A is. Again, so sine is opposite over hypotenuse, 4/7. So to get the angle, angle A is equal to the inverse sine of 4/7. So inverse sine of 4 divided by 7. And we get 34 point, it says to round it to nearest tenth, so it's 34.8. Now for angle B, what I could do is I could set up another trig function if I wanted. I realized I just found angle A incorrectly. And nobody stopped me. You know why nobody stopped me? Because I'm recording this in my house and my cat doesn't know geometry. Opposite over hypotenuse so now I'm now going to get the right answer. Right, square root 65. All right, angle A is 29.7. So now you have a couple options to solve for B. You could set up another trig function if you wanted. I messed up this trig function, so I'm not going to do that. The angles in a right triangle are complementary. So I do 90 minus 29.7. So I do 90 minus 29.7. And this is what angle B equals. Angle B is equal to 60.3 degrees. Okay, I apologize for that little error in there, but you'll see if you're watching the whole video. Okay, so again, I apologize. Everybody makes mistakes, but that is my video on trigonometry. I think it's funny that I made a mistake in my favorite topic, but it is what it is.